Hey gang. All right. Now we're going to do part two of balancing equations. So when you get comfortable with the introductory stuff, you can jump up to equations that have parentheses in them. Dun, 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 dun. All right. So here is what's called a polyatomic ion. So this right here is a cluster of atoms that have a net charge. So when you bond it, it looks like this. All right, there we go. So now we have a net charge of 1 minus when you bond that together. You don't need to worry about bonding that, but all you need to know is how to handle it when you see it in an equation. So what do you do? Well, the first thing is when you encounter it, you're going to take any number outside of the parentheses and distribute it to each thing in the parentheses. So what this means here is that you have two N's and six O's. Okay, that's what that means. It's just written differently. So, how you do this type of equation, there's two ways you can do it. So, we're going to do it the normal way. So, that's where you divide it in your two sides, reactants and products. And then you write your individual elements down below. So, then you get rubidium, nitrogen, oxygen, beryllium, and fluorine. And then over here, we're going to do the same order, even though it changes in the reaction. So don't switch your stuff around, because if you do that, then you're going to mess up somewhere. And let's start counting. Okay, so I have one rubidium, one nitrogen, three oxygens, one beryllium, and two fluorines. Side two, I have one rubidium, two nitrogens, because you use the distributed property, six oxygens, again, same reason, and then because you get 2 times 3 O's is 6, and then Be is 1 and F is 1. Okay, so now what do I do? Well, your rubidium looks good, your F does not, and neither does your nitrogen. So what we're going to do is remember, you can't just add nitrogen out of nowhere. So you have to add it how it's written. So if it's written as RBNO3, that's what you need to add. So then you get two nitrogens, also two rubidiums, and now six oxygens. So now nitrogen and oxygen look good now. These guys are balanced. Rubidium is not. So I need more rubidium and fluorine on the right side. Conveniently, they go together. So I'm going to add RBF, and now I have two rubidiums and two fluorines. So now I balance the equation by writing in the coefficients. I got two of these guys, so I write 2. I've got one of these guys, so I write 1, and 2. So it's 2, 1, 1, 2. Now there's another way, there's a shortcut you can take when you're dealing with these, and I'm going to do it this way on the next one. Okay, so I'm going to go ahead and, you know what, I'm going to actually skip down here. So, ooh, yeah, let's do this one. Okay, this is a killer one to show the shortcut. Now, notice that we have two polyatomic ions here, okay? We've got one, as in Cn, that is grouped together. You also have SO4, which has a net charge of 2 minus. That's not in parentheses, but you can see that it's grouped together in the same formation. So here's the shortcut that I was talking about earlier. And again, if this is about to confuse you, don't worry about trying it. So instead of breaking each element up, if it's together in an ion form, like Cn or SO4, you can keep it that way. So instead of totaling your C's or your N's, you just total your CN's and your SO4's and your copper. So now this kind of chunks your counting a little bit and it makes it a little easier. Keep them on the same order and CU. Again, this is just a shortcut. You do not have to do it this way. If you're good breaking it up into individual elements, just do it that way. All right, I got one hydrogen, one CN, one SO4, and one copper. Two hydrogen, one SO4, and then I got one copper and then two CNs. So I need two CNs, so I add HCN over here. Boom. Now I got two, and I got two. So those two look good. And then SO4 is good, and as is Cu. So it looks like I am balanced. So there we go. All you need to do is just add a coefficient of 2, and then you get 1, 1, and 1. So that's the shortcut method where you just keep them grouped up together. Okay, that's balancing with polyatomic ions.